Hello students, myself Sanjeev Pal, Assistant Professor of W Department of Regent Education Research Foundation and Group of Institutions. In my previous lecture, I have covered the statement of Gauss's law. Here I will explain or prove how to prove the Gauss's law. So, as we know the expression, this will be the expression. Okay. So here we know closed surface integration of d dot ds. So I will explain by using this drawing, and it is also the volume integration. It will be also explained through this volume. What I have drawn, initially I considered this unsymmetrical shape. Inside this shape I consider a point q1, it is the charge. So in that particular point, I have considered a single point charge is here and its value is q1. Now on the surface, here we consider a very small area. This is ds. That is technically called differential surface. So this is the actual surface. Now I have drawn a dotted line to make a cone, and I drawn another dotted line. This is actually at the center of that surface, or it is axis of that particular cone. So through this direction, mind it, on the surface of this ds, on the differential surface, I have considered unit vector, unit vector for e, unit vector for d, unit vector for a r. R is the radius and it is defined or denoted by I suffix r as the unit vector representation. And the angle here, as per the diagram, it is d gamma, that is the cone angle. Okay, this is the explanation for the diagram. Now, we know the formula of electric field intensity of a particular charge q1. It will be written in such a way: u1 equal to q1 by 4 pi epsilon r square ir, and it is the expression of E. And from here, d1 you can write epsilon E. So just put the value of E1, you will get the value of d1. So this is the expressions. Now I have to consider this formula, closed surface integration of d dot ds. So in place of this, I have considered closed surface integration of d1 ds. So here d1 ds, and you just put the value of d1, q1 by 4 pi r square. Okay, and this unit vector ir is there. So d1 is here, I have written next dot next ds. So I have to give a bar. Now q1 4 pi, these are the common, you take outside these expressions. So before the integrations, before the integration I have considered the constant part. Now this inside the constant integration, what I have written, ir dot ds. Ir means unit vector, actual magnitude is 1, so it is ds. ds into 1 means ds. And for the dot you can write, this is cos theta. This is the formula of the dot product. A dot b will become a mod b mod cos theta. Theta is the angle between e and b. So here theta is also an angle between ds and ir. And you know what will be the ds and ir angle. This will be a same line, and there the angular displacement will be 0. So cos theta will become 1. So whatever. So initially you write this ds cos theta, and this r square I have considered over here. Now this portion is defined by d gamma, and the closed surface integration of d gamma is called 4 pi. Now you consider 4 pi will cancel out. You will get only q1. So closed surface integration of d1 ds will give you q1 charge. Next similar way for the d2 surface will get q2 charge, and the simultaneously if we consider lot of point charge and you add the all equation, you will get such a equation, and this equation you can write in a compact way that summation of summation or the d1 plus d2 dot dn, you can write d and dot ds you put over here. This is the closed surface integration, and that will give you the total charge, and you can write this total charge equal to capital Q, and you can write enclosed here. So this is the proof of Gauss's law. So very short video. Okay, any doubt you can comment. Video ভালো লাগলে like and share. Thank you.